Welcome back to my channel. This is the third in a series of videos which is called Master Databricks and Apache Spark. Databricks is a user interface wrapped around Apache Spark, but it is a commercial proprietary service. It was created by the developers of Apache Spark, and we're going to learn more about that. But if you are jumping into the middle of this, you probably want to go back to lesson 1 or even lesson 0, which gives you sort of an overview of the series. In this particular lesson, what I'm going to do is a demo of the Databricks workspace. My name's Brian Kafke. I'm a data and AI enabler. Let's jump in. Now I'm going to switch things a little bit because I created my Databricks workspace in the last video, but I'm going to use a different workspace now. A little bait and switch, mostly because I have some things already created in the Databricks workspace I've been using for a while for doing different things, including my book. So I'm going to go into one I created a while ago called ADBWS, which is Azure Databricks Workspace. The AW is because we're going to be using AdventureWorks data. So once we're in the portal, we can find this here, or we could go to the dashboard to find it. I'm going to go in here. Once we get into the overview blade, we can just scroll down here and launch the workspace. Notice you'll see a screen pop up for a very short time, and it's using Active Directory, Azure Active Directory, to authenticate who I am and bring me into the workspace. And that's actually one of the key benefits of using Azure Databricks together, as opposed to, say, just Databricks on maybe AWS. One of the things that you get is if you do use, so this is a benefit that if you use it, makes sense. Since Azure uses Azure Active Directory, it integrates automatically with who you are and authenticates you, so I am automatically dropped into the workspace when I click on it and, as you saw, open it, and I don't have to enter passwords. I don't have to do anything. It already knows who I am. It's authenticated me. It's already determined I have a right to see this, and that's true of anyone who gets into this workspace. If I've granted them access, then they could get in and they will be able to do this. So again, kind of a slight thing, but what's really cool about it is it makes it for nice seamless integration when you're using it. Now, as we are in the workspace, you can see on the left we've got a toolbar of icons, and these are really the menu options we have. We start at this top level one, and we can see these are notebooks I've recently been accessing. These are common things we want to do, right? And I could go here and say create a cluster, but I'm going to go to the cluster menu here. Even though we've got this nice little workspace, Spark is all about having a cluster. And we talked about before, a cluster is a collection of really virtual machines, or now with Kubernetes and containers, a set of containers at the very least. Basically, it's meant to execute separate processes in parallel. And we saw in my first video, I talked about how we would split up a large data set into chunks called partitions, and each machine or container, but whatever it is, it has to be a separate process, and we call those nodes, right? So each node is going to get a separate chunk of data, and they're going to process it in parallel. This is hidden from us. The complexity of that's hidden from us, but we have to create the cluster, and we do have to tell it some things before it can do that. Now, one of the nice things about Databricks is we can go right into this cluster menu and just create a cluster here, saying by clicking on Create Cluster. We can just give it a name, like I don't know, I'll call it Databricks. We'll call it just Databricks Demo. And once that's just the name we're going to give the cluster. We can create any number of clusters, and this is again a feature because we can have any amount of clusters and we can turn them on and turn them off, and different people can use different ones. We can share, and that's a feature because in HD Insight, as we'll see later, we create a separate cluster. Each one is handled differently, and we would go into each cluster separately. So this ability to manage and orchestrate them is a nice feature. Now we also have the cluster mode. We have 3 choices, and one of these is actually pretty new, but high concurrency is meant for when you have a lot of people and you want to share the same cluster. Standard is pretty much your sort of standard Spark cluster. It's not meant for high concurrency and sharing, all that stuff. Single node is interesting because apparently it's a new thing where you don't have to create worker nodes and you can kind of work really scaled down. So I'm guessing it's meant for training. If you have trouble getting Databricks to work and it won't let you create a standard cluster, which I'm going to do, I'm going to try anyway, because I do sometimes run into limits, just try single node, because for what we're going to be doing, it'll work fine. But I'll say standard because I want to demonstrate some things here as well. Now, typically, I will just take the default here, but you have a runtime. So there's things in here. The 7.5 ML is for machine learning, so it's got some machine learning services added onto it. 7.5, these are some of the more newest ones. 7.4 being the default, I'm guessing is probably the most stable and recommended, we might say. Also, GPU means it's those graphic processing units. So that's meant for when you need high-speed number crunching, that kind of thing that can do really arrays processing well and fast. GPU is really good for that, but they cost money. So I'm going to go with the cheapest I can get because I'm just demonstrating, right? We can say enable auto scaling, and auto scaling allows us to select a minimum and maximum number of workers. Each worker is a separate process working on a task, right? It's split up. And 2 to 8, for instance, would mean that if there's a low workload and it can handle what I want with only 2 workers, then it will do that. If I start adding more and more volume to the work and it starts to need more memory and more processing power, it will scale up to my maximum workers. So we'll add more workers until it reaches the max. So at any given point in time, my cluster will have anywhere from the minimum to the maximum. It will not go below the minimum, it won't go above the maximum. Because that's the idea of this whole thing. I actually want to say I'm not 100%. I think it may actually go down to 1 if it really doesn't need even 2, because I have seen that sometimes. But this is the idea of the minimum and maximum. The other thing we'll notice here, I forgot to mention, is the runtime is the Databricks runtime, which is sort of an enhanced version of Spark, and it has some performance improvements and things like that. If you're familiar with Python, it says Python 3. Python, there had been a previous version of Python which was stopped at Python 2.7. There was some backward incompatible changes made to Python that all started with Python 3 and up. At this point, 2.7 has been deprecated, it's no longer supported, don't use it. So you'd have to go backwards in versions to go to 2.7 as the last version, but I wouldn't recommend it because 3 is the latest. Okay, the other thing I want to point out here is this terminate after. Let me see if I can also show this a little bit. So this terminate after number of minutes, I would set this even to, you can set this to like 30 minutes. What that means is if there's no activity on this cluster, you go to lunch or something, after 30 minutes, it will just terminate the cluster. It's really deleting the cluster, it's just removing it. But from a database standpoint, as you'll see, it doesn't look like it's gone because it actually stays there, and you'll see it's just still sitting there, and you can restart it at will. And we'll be doing that a lot when we go through these exercises during the video series. So this is really handy because it's an extremely cost-saving value of Databricks. I can just, this is like an auto pause, which means I won't pay for any compute when the cluster's turned off. And looking at the metrics Microsoft generally says is you pay by the minute when it comes to the cluster usage. So that could change, and check it. Maybe I read it wrong. I don't want to be held to any bills, but what it looks like is it's tracking how many minutes have you used it. Once the cluster terminates, you're not paying for the virtual machines under the covers, all that compute hardware. That is by far going to be the most expensive part of Databricks. I have kept my workspace around for a long time and it cost me almost nothing, but the compute power does. So the long and short of it is that by setting this to say 30 minutes, I'm going to be paying very little for my cluster if I don't use it all the time. So if I use it for an hour here and there and then go away, I have found it to be very cheap, like really a few bucks here and there. When I was writing my book, again, I kept it to like a 2-node cluster, admittedly very small, but I was able to use it, develop queries, small data. I wasn't trying to do very big data volumes. I was using data sets like we'll be using, and it was great for that kind of thing. So from a learning standpoint, it can be cheap to do this. You just got to really watch this and set this as low as you want. It's not going to hurt you to even put it to 15 minutes if you like go away and you don't want to pay anything extra, because you can restart it and in about 5 minutes it's back and running. Okay, that's my lecture on that. So we've got that set to 30 minutes. I'm going to say this, I want minimum workers 2, and I'll set the max to 4. Let me try even, I'm going to even try going 1. I think that's why I was able to go to 1 before. I'm going to say 1 to 2. That's a pretty minimal size cluster. You get this little here, it's warning you it may not be enough. If you try to ask for more workers than you have resources available on your subscription, you get into trouble, and I've seen that a lot, so I'm more worried about hitting a problem there. We're going to be using small data volumes, so I'm not too worried about that. Generally, the driver type on the workers, you're just going to let it default to the same driver type. Now, I will point out that on both you have this option, both the head node and the other node. I believe the other one we have the same kind of option. Just the basic, sorry, that's just the runtime. On the workers, what we can see is it's the scale of the virtual machines. What type of virtual machine under the covers do you want? This is where you're determining how much you're going to pay for your cluster. I try to go with the lowest end for what I'm doing for learning, but if you're in a real world environment, you're going to want to try to figure out what makes the most sense. If you were doing something like a deep learning neural network, right, you may want like a GPU, and you may want to pay for it because it'll do what you need quick, and you can terminate the cluster. So it's a trade-off. You have to figure out what makes sense for you. All right, and some may not be available in your region, etc. So you also have to consider that. We go down here, advanced options, and a lot of times the pages in Databricks, which this throws me, it'll expand. So advanced options, you couldn't do anything. Click it and it expands, and we're going to see more of that. So this is something you can also do, which is enable credential pass-through. I talk about this in my book, which allows me to do things and automatically credential that I have access to something. We're not going to worry about that right now. We're not going to try it. The other thing you'll see is with the Spark config and the init scripts. And what these allow you to do is tailor the Spark cluster to do things like set configurations a certain way. The init scripts allows you to do maybe installations of certain libraries or certain customizations that you want. So there's a lot of things around that. We also have some logging options, so we can go in here and say we want DBFS. DBFS is another value added. It's the Databricks file system, and what that does is it simulates a local file storage within Databricks. So we can like treat it like a folder. We can look, and we're going to see using that. I'm going to leave logging the way it is, but we have some options there. Tags. We've seen tags before. There's some built-in tags here, so people can look at my workspace. If they were here, they could see things like whose workspace, who created this, what's the name, etc. And of course, we can add our own tags. So a lot of things we can do here. I'd say the one takeaway is the same things you could do with a Spark open source cluster. You have access to all those kind of configurations and settings here, plus, of course, additional things that you get with Databricks. So I think we've got all the things we are really going to need here. I'm creating a very bare minimal cluster. One thing I also wanted to mention is this pools. This is a fairly new feature, which is cool because Databricks is already very fast at creating a cluster. For raw small clusters, and generally it's pretty quick in general, even for larger clusters, but it will probably take a little over 5 minutes to create a cluster we can use, especially 1 to 2 nodes, not a big deal. However, you may be somebody who's a high-powered user in your business, your research facility. You can keep instances on standby, and by doing that, it tells you here, when you want to create a cluster, you can create a pool, and then you can define, like I don't have one, but if I had a pool, it means that it's going to kind of keep some warm VMs backed up. They're ready to go. I'm going to have to pay some money for that. But if my biggest thing is I want to be able to get a cluster up and running fast, and I don't want to have to wait, then it might be worth it. Maybe downtime. If you're paying somebody a lot of money, some consultants, not me, but some consultants charge you a lot of money, it might be worth it. Whatever it is, you really under a crunch, whatever, the pools can be really useful. It's not, the biggest thing it's doing though is just helping you get the cluster created quickly. The speed of creating a cluster in Databricks is about 5 times faster from what my own experience than doing it, say, through HD Insight. All right, so I think we got everything here. Gonna see if I can create my cluster. Okay, so that actually took, I want to say, about 3 or 4 minutes. I didn't time it. It was actually faster than I remember. So apparently they've even made some improvements in the short time since I last used Databricks, which is pretty cool. What we can see once we're done, you can see this goes green. That's the that little circle tells us the cluster is ready. Now I want to show you some other things though, that now that we have it running, if we had notebooks running on the cluster, we can just click this tab and see them and what the status is. Libraries are third-party libraries, in other words, ones that aren't pre-installed for you on the cluster. An advantage also of Databricks is a lot of standard libraries are automatically included for you, which is kind of handy. But if they're not, you can see here we have a little button, install new. There's a GUI you can walk through, and we will do this, where we can install a library that isn't already included, and we're going to do that as part of our training here, so don't worry about that. But this is pretty cool too. We have an event log we can see here, which is cool. We also, it's important to understand too, we are running Spark and we have access to what's happening in Spark, which is the UI. So we can look down here and see the user interface for Spark. We can see the driver logs going on here. We can look at metrics. And this is improving all the time, I have to admit, because there are things that weren't available here when I first learned Databricks a couple of years ago. Nice thing here too, you can see there's support for RStudio Server, a web terminal, so kind of cool things there. And you can also go to the Spark UI master, and again you can see things that you would normally go into, log into the Spark UI. Again, you can see the Spark symbol. This is just your open source Spark as far as I can see, but the runtime around it is Databricks. All right, so we have our cluster running. I'm going to click over here. Okay. Sometimes I will mention too, in the UI, sometimes you actually have to refresh the browser because things won't show up. So we can see this has a status of running. It's got 2 nodes. We can see the runtime. We can see these, all these kind of cool things, which is great. So we're good to go. Data next. We have a cluster running. We don't have any data to work with. One of the things we can do is we can upload data because fortunately for us, we have built-in blob storage. In fact, you can see I've been doing a little work here. I have a lot of stuff, partly from doing my book, partly from doing demos. I got a lot of stuff here, but I'm going to pretend I don't. And what I'm going to do is I want to walk through uploading a file. So normally you just see this default. In your instance, you probably just see this one folder default, but I've got some other pseudo databases. They're really just namespaces. So I've got default. What I'm going to do is say create a table, create table here. And then this is not an intuitive interface, admittedly, but what I'm going to do is I've got it defaults to uploading a file, and you don't click here, but I will say when I upload files, it will go into DBFS file store tables. We're going to see this in our notebook. What I'm going to do is click in this little browse. Hopefully you can see this. I've got a file in here. It's in the zip folder that you can get off GitHub for this particular demo. I'm going to click on that and say open, and you'll see that AW product is now showing up in this files area. And then you can only really, the way I'm going to be doing this is manually stepping through and defining a schema on top of the flat file, the CSV. One of the things that's nice about Spark is that it has something called schema on read, meaning that unlike a relational database in which you have to ingest any data from outside into a table, which is under the control and format of the database engine, we can just define a schema on top of a file, and we don't even have to import it. We don't have the redundancy necessary of importing it, nor the time spent loading it in. So that's a really handy feature for large files because we can just query them in place. Now, I mentioned here, you can see this is where it uploaded it. Because I've already uploaded this file, it automatically increments a number on it, this time AW product-4. Now I'm going to click here, create table with UI, user interface. Then you can scroll down, as mentioned before, you get this. Okay, now I can scroll down, right? I need to pick a cluster, so I say the cluster I have is there. Can't scroll until I click the preview button. It's now going to show me the table. On the right, it will show how the table looks, and we can go through the GUI to now customize this. So I'm not going to use, it always puts the file extension at the end of the file name, which I'm not a huge fan of. I'm going to call it AW product. Now that already exists, but I'll call it demo because that does not. So AW product demo. You can call it whatever you want. This will, however, be the name in SQL you will need to use to refer to this table. We're actually taking it. We've already uploaded the file, but we're going to create a schema on top of this. It uses a Hive, basically uses what was Hadoop Hive over the table to allow us to read it. So it's a pretty cool feature. So they borrowed some good things from Hadoop. We're going to leave it in the default database. The file type's fine. I'm going to, in this case, you can see the first row has headings. I can use those as the column names in my table. The other thing that I want to do is it automatically is going to default to all the columns being strings. I can check this infer schema, and it's going to read the data and define what it should really be. Not really much here, but you do see a couple of ints, things like that. This is a good way to start experimenting. It's good for small data sets. I'm going to show you other ways that we can do this that work better later on, that you can use bigger data sets, and we can even connect outside of the local blob storage, which is the Databricks file system storage. We can connect to Azure Blob Storage, any accounts, etc. Okay, this should be good. I'm going to say create table. Again, just to remember, it's called AW product demo is our table name. Create table. Takes a few seconds, and really nice here, it gives me the schema of my table. Again, this is just a schema on top of the flat file, and it shows me sample data. That's about it right here. I think we have what we need. So what I want to do now is I want to show you how we can read this. The tool of choice, the only tool really that we can develop things within Databricks, is using the Databricks notebook. So I'm going to start by creating a new notebook, and one of the things you'll find is you can create things right here, but users in a workspace will have a folder structure. This workspace, let me back up for a minute, because workspace is a very confusing term because it's used in at least 3 different ways in Azure/Databricks. Azure uses workspace in different instances, not just with Databricks, to refer to something which is a set of resources that provide a service, like the Azure ML workspace, and in this case the Databricks workspace. Once you are in the GUI of Databricks, which we are here, that is also referred to as a workspace. That's actually the Databricks name for it, which Microsoft isn't going to change because that's what they call it everywhere in the documentation. So we have a second definition, and I'll typically call it more the user UI, or I actually like to call it the Databricks portal, because that's what it kind of looks like to me. It's a portal within just for Databricks. All right, there's another sort of workspace you can see here, which Databricks uses to refer to also the sort of file storage arrangement, the sort of visual way it's presented. So under this we can have shared, which everyone can use. We can have users, and we can create folders. I've got some folders I've created. Under users we have my account, and we can do things there, or I can just go into workspace and say I'm going to create a notebook. Okay, so let's create a notebook, and I'm going to call it ADB demo. Right, I can pick what language do I want as a default. Now Databricks notebooks can use pretty much any language that's supported by default. The only restriction, at least I have to check, but the only restriction used to be when you're using the high user clusters, the one that we could create, which is multi-user, that we didn't create, that doesn't support Scala if you do create one of those. But the normal standard clusters support the languages you'll see listed: Python, Scala, SQL, and R. Those are the languages that are supported by Databricks notebooks. Now bear in mind, you can use all of these languages within a single notebook, which is unusual if you're used to using a typical Jupyter notebook, because you always say, okay, the notebook language is Python, the notebook kernel language is X. But in this case, it's really more of a convenience. Like, what do you want me to use as the default? So if you don't tell me what the cell language is, then I'm going to use that. I'm going to use SQL for this, and then I'll just say, okay, create. And now I'm in a Databricks notebook, and we have these cells. If you've ever used a notebook before, I think I might try to make this a little bigger for you. Unlike Jupyter, in which you control the cell type from the menu, here you do it with a cell magic, and the cell magic is a percent and some sort of little tag, which in this case is MD. We're going to create a nice label for this. MD means Markdown. Markdown is a sort of abstraction above HTML. So we can have things like H1 tags, H2 tags, but the syntax is simplified. For instance, an H1 tag is simply a single £, mean this should be treated as an H1 tag, my swell demo, and I can do like 2 of these to get it a little smaller, by Brian Cafferty. I can insert pictures and things as well. I run it, and doing Shift Enter, which is sort of the ubiquitous standard as well in Jupyter, will allow me to run this cell to render it. When it has the %MD, that is not meant to run code. That's simply meant to support annotations, documentation, if you will. All right. Now, there's a lot of things in here, and we will do a more detailed walkthrough of notebooks and how to use them. But one of the things we can do for a keyboard shortcut, if you're like me, I like to use keyboard shortcuts. You can just click on that thing over there, this little keyboard, and it will bring up a whole document list of what all the keyboard shortcuts are, the sort of cheat sheet. Great. Now we have a macro. We want to use the SQL language. We can say %SQL. I'm going to put it in there to make it clear this is SQL, Structured Query Language. But because the notebook itself, if I highlight here, right up at the top, the notebook itself is an SQL notebook. I don't technically have to tell it this. I could do it without this. But what I'm going to do here, and I like to use all uppercase when I use SQL in Databricks. I'm not sure why, but I can say from. And remember, we uploaded a table, right? We just uploaded one, AW product demo. You just run that. And you notice a few things. First of all, when we run something that engages the Spark cluster, it will show you this little Spark job, and you can actually go in and view what happened in the Spark cluster. You can, step through for performance tuning, look at how it satisfied the query, etc. So you're not cut off from that, which is really nice. But we're not too interested in that right now. We're just showing you how to use things. So notice we're able to use the structured query language, SQL. Nothing on my sleeves, it just works. I uploaded a CSV file, and now I can query it just like it was a table. I will say it is not a table. It is just allowing us to take this CSV file, and it has a schema defined. It knows what column names are, etc., and the data types, and it's just now going to query it without loading it, which is really good. What Spark has really done, what Databricks has done, is it's taken this table and split it up and divided it and loaded the data into the worker nodes. Okay, so it's actually using it now. It is partitioned, but we didn't have to tell it how. It did it by defaulting how it would partition, and it just did it for us. All right, so we have this. This is great, and I can use extensions to the SQL, like limit 5 will just give me the 5 rows. We can do that. All kinds of stuff here. I'm going to walk through again in more detail in another video, but we have things here. We can do a new notebook, we can clone a notebook, we can rename, all these kind of file-ish functions. We have a revision history that's being tracked for our notebooks. We also have all these cut cells, copy cells, so we can move cells around and do things. The notebook is a program. That's all it is. It's unintuitive to a typical, say, app developer, or web app developer, or anything like that, because they think of just code. But because analysis and model training and data science is very iterative, you got to explore, you want to see visuals, you're kind of exploring your way through the data. Notebooks are a lot more popular because they allow you to do this in a very iterative way, but notebooks can be executed just like a program, because they are programs. They're just a script as well. They just support annotations, and they have some extra features like visualization. So we have a lot of other menus here. We've got this one. We can see what do we want to see. So if I said I want to see results only, I could just see the results of the notebook, and I don't see the code. I could say standard, which shows me both, so I can control those kinds of things. I can hide line numbers if I don't want them, show command numbers, etc. I can also do dashboards, and I'll see that in a minute. I can set permissions here, and what you can do there is I can actually add other people. Assuming people are in the workspace they are allowed to get in, I can say, Mary can read and edit my notebook. You got the options here. I can add somebody and say they can run, edit, and manage. So again, this is ways that we can control the security of our notebooks, and that's a common theme throughout the different objects, clusters, notebooks, etc. Okay, so I'm kind of skipping here. I can run all the cells in a notebook by clicking this little button here. I can clear out results. So if I clear out results, I can say confirm, and notice now that grid went away. I can just run the cell again. Control Enter will run a cell that you're in without advancing, and Shift Enter will go run the cell and advance to the next cell. We have the ability to schedule jobs. I've said that notebooks are jobs. scheduling it will mean that I can take this notebook and say, I want you to run this at a certain date, on a certain time, recurring, single time, all that good stuff. Nice feature is I can even tell it I don't have to have a cluster running, and the notebook can be set in such a way that it will just create the cluster, run the job, and then delete the cluster. So that's a good thing if you don't want to have to keep a cluster running all the time for batch jobs. And it is the default in when you schedule batch jobs. We have the ability to add comments to the side, which we can enter. ML flow tracking, this is a pretty new feature, but it allows us to do essentially a DevOps type of thing called ML ops, and tracking and scheduling and all kinds of cool stuff around machine learning. We're going to do that much later towards the end when we get into the machine learning end of things. We can look at a revision history, so you can see every change I'm making, what's going on, cool stuff like that. Now we can also, I'm not going to get into this, but you can also, if you want to connect this to something like GitHub, you can do that as well, and it will track things and keep it so that you can keep version control over it. Okay, we've got, just trying to think of a few other things here. You can see here, this is the cluster. So if I had multiple clusters running, it would ask me, well, which cluster do you want me to be running this on? Now, the notebooks themselves never go away. They'll be stored on blob storage. So even without a cluster, we can still get in, look at our notebooks, but we can't run anything without a cluster because that's where the compute is. The data that we uploaded will disappear because actually the data is loaded to the cluster. So when the cluster shuts down, we can't see the data, but we can still see and access our notebooks, which is really handy if you just want to go look at code or maybe download a notebook. You don't need to be running a cluster. All right, so we've got that. We've got each cell, and this is another thing. I actually really like this a lot over, say, Jupyter Notebooks. Each cell has its own local menu, so I can say cut, copy, insert, etc. So that's kind of nice. I like that. I can also use this, which allows me to take any output of a cell and add it to a dashboard. We'll see a little bit of that in a minute. I can compress what's visible with this plus minus toggle, and if I click on the X, it will delete the cell. So I've got all that. So that's the basic premise of what we've got going on. So we've got documentation cells, and notice, we don't see the format of an MD Markdown. Once we execute it, it just shows us the text. Code cells, though, typically will have the tell you what type of cell it is, what it's going to actually be running, and in here we can see it's running SQL. All right, so we got SQL here. That's great. One of the things I also want to demonstrate while we're doing this is bring it in like this. What's cool here is, notice it only shows us a few rows anyway. There's a limit here, by the way, I should mention, because it took me a while to get the hang of what's going on. This is actually a Spark dataset, and it's, again, I mentioned it's distributed over the node. You might be wondering, well, gee, it's showing me a list. What if there is a trillion rows? Which there could be. It will limit what it retrieves back to 1,000 rows, unless you override it, which we'll see in a minute. So it's only showing us, in this case, we don't have more than this many rows, so we're okay. Now, one of the cool things is I have visuals available. I can click here and I have some different options available. I can say I want a pie chart. Now, it's defaulting to what exactly it's showing me, but I can go in here and I can change it with plot options. So let's say, get rid of this. I'm doing it now by status, and maybe I want to do something like, instead of sum, which isn't useful because this is all just text columns, I'm going to say count. So I'll count, and it really doesn't matter what I'm counting. I'll say values. And now what I'm doing really is I'm getting a count of the status, current and null. So apparently it's either current or it's not there at all. We can see 33% are null. Probably not too useful. Let's get rid of this. And I'm going to say something like style. Now we're getting a style which shows us UWM. That's not really helpful either, right? Let's see if we can find something that's a little more useful here. Try model name. Okay, so we got a breakdown. Let's leave that. And maybe instead of pie chart, I can go over here and I have all these options. I'll go with the bar chart because everyone loves bar charts. You can see one thing over here. The null apparently is the winner here. Let me shrink this down a little bit so I can show you more. So I just want to show you in this customized plot screen. This is incredibly useful. We can do a lot of really useful visuals with no coding. So I like this a lot, and this is available in the free Databricks edition as well. So we can do counts. Now if we had a column in here that was useful, which I guess we do. Let me look here. I think we have list price, right? So let's get rid of this. I'm going to go list price. And instead of count, I'll say sum. And now we're getting a sum by list price of what we have, all the different products. So we can see a lot of things in here. We could change this maybe to see how a line chart works. So a lot of flexibility. We can change the color we want. Global color consistency tries to get some consistency over the notebook itself. Let me just back up a minute. Now when I say apply, there's a very unusual thing happening here, which is it's going to apply the query. It's going to re-query the back end, which is kind of unusual to think of, and it took me a while again to get that. I can resize this because that's not very pretty looking. And I drag it out and there it is. So I don't want to get too much into notebooks. We'll see that later. We also have some things we can do here, and we get some nice, help. It's more interactive than you might expect. All right, so let me do a little more of a demo. And we're going to go in and actually I can go back here where I was working on one. I'm going to use a notebook example just to give you a quick idea of things you can do. So this was a preliminary data analysis that I was working on. It's in my book. And we're going to use a CSV file. And this one is AW Internet Sales. We don't have this loaded. Oh yeah, we do. No, we don't have it loaded yet. So let me bring the data up for this. And I'll say create table, browse. Now this one's called Fact Internet Sales. So I may have to change my notebook a little bit here to make this work. This one's a pretty good sized table. It's you can see it's almost 12 megabytes. Create the table with the UI. So we're going to go through the same thing again. We only have one cluster, but it makes me pick it. Preview the table. I'm just scrolling down. Now I'm going to actually do something here. Even though the table coming in is Fact Internet Sales, that's the name. I'm going to call it AW Internet Sales. Now it says it already exists, so I'm going to just add the word demo to it so we can see we can do that. Again, I've already got a lot of these things up here. What I want to do here is say the first row is a header. I'm going to also ask it to infer the schema. Again, there's a lot more data here, so it takes a little more work to do that. And once I'm done, I can just say create the table. And it's AW Internet Sales Demo. Get all this good stuff. And let's go back to the notebook we were working on, notebook. And so I should be able to run this. Now I said Internet Sales. I should be able to say demo now. And notice if you're not attached to a cluster, you'll be asked to attach to one. If you have one that's paused, that temporarily, it'll automatically ask you, do you want to start the cluster? So we now are using our new table. A nice thing too in the notebook is it remembered the visual we had. So even when you refresh it, it will keep it in place and refresh the visual. Another nice thing is that if you share your notebook, you can actually share the notebook with somebody. You could even download, export it into a Databricks compressed DBC file, give it to your friends, trade with your friends, whatever, and they will see the output. That's another benefit of notebooks. They can see what you did without having to run it again. Okay, again, we can do all those plot options, same things we looked at before. So I'm just going to show you also we can run Python. Now this is using just generating a random number, but we can see that we can run Python code, and that also is coming out in our output window. We can run Scala code, and again we keep using these little magics at the top. Now in this case this is a Python notebook, so Python doesn't really need us to tell it. We didn't say here that it's Python. Scala we do. R, we can run R code by using %R, and we can run file system command. So one of the extensions is not only are we able to just upload a file and query it, which is really a value add for Databricks, but we have this FS command, file system command. We can say FS file store, for instance, and it's going to query as if that's a subfolder. The drive name is dbfs:, so it's actually just like a drive, and you can see I got a lot of stuff out there. We can also do things like sh commands, like I can do command looking for the manual on bash. Again, Scala code. If I want to see something nice, handy commands are like I want to see, gee, what tables do I have? I can say show tables, and this will show me all the tables I've got, scrolling and everything. So I got a lot out there. If I wanted to get this is something I always need to do. I'm always forgetting what's the column names, what's the types. Describe table, if I do that, that will describe a table and tell me like the types and stuff, so I can use that in my queries. Now, one of the other things I did want to show you is I can also go over here, let's see, here, and I've created some dashboards. I can actually go to the dashboards here too. Where did I put these? Okay, so I have a dashboard here. I've already created tagged some things to my dashboard, and there's not a lot here, but you can see that I could build a dashboard from this. I say present dashboard, and now I can share it, trade it with my friends. What's nice about the dashboard is I can create as many dashboards as I want, and really the dashboard is like a view into my notebook. It's meant to be tagging visuals and things that I think are important. I can make them a dashboard, and then I can share them with the team. I might take certain key visuals that are aggregating, showing some important findings in research, and put them into a dashboard, and then management can just look at the dashboard, and I can give people access to see the dashboard and all kinds of cool stuff. So you can almost get like a sort of poor man's Power BI doing this. I think I have a video exactly suggesting that. It's not as advanced as Power BI, but it's really useful because it's all within the sort of Databricks team. So if you have a data science team collaboration, this allows you to sort of provide different views into your research. I'm going to click on the exit to get out of this, and I can go in here and just go back to standard, and now I'm back in my notebook, so I can toggle between these different views. Okay, so that's shown us kind of a quick view of notebooks. Let me see what we haven't seen. We've seen notebooks. We saw another thing we can do. We can go and say create a notebook, but we can also import, and we can import notebooks from URLs or from files. So I mentioned the DBC files. That's the extension. We can import them from other people, from ourselves. We can export to a DBC or HTML. We can again set permissions. We can sort. I have not tried copy link address, but sounds cool. Okay. The other thing I didn't mention is we can create libraries. So let's look at that for a minute. Libraries are interesting. If you are familiar with Python, the languages I use mostly are Python and R. So Python especially. So I can click on PyPy, and if for some reason there's a library I want to use, things like pandas and things are already available. But let's say I want to use, I don't know, SQLite module that's not available or something, then I could use PyPy and install it. Now, one I know just off the cuff is one called Psych. I may already have it, but I could then say I want to get the Psych package from R. I can say create. It comes up here, and if you click on install, the thing to bear in mind is when you install libraries, it must install the libraries on the cluster nodes, which can take a little time. So I would never choose install automatically unless I really had some package or library that I thought everybody should have all the time because it's so awesome, because that will add time to the startup of your cluster. So it can be a bad idea to just add a lot of things to your cluster. Okay, I'm not going to get too much into the libraries, but you can bring in Java jars because Scala is a derivative of Java and it runs in the JVM. So any Java libraries you like, available in Databricks through the Scala language. You can also use PyPy, etc. So you got a lot of options with libraries. This is another value add because if you were doing this on, say, open source Spark, you'd have to make sure you install those packages on your cluster nodes, and so there's a lot of work involved potentially in that. Delta Lake is a pretty new feature within the last couple of years for Databricks, and I'm probably not going to talk about it in this series, but really eager to get through this series so I can cover more about it. The bottom line of what Delta Lake is it's simulating something more like a relational database. Remember, I mentioned you don't ingest data in Spark. It's just reading it where it is. With Delta Lake, it uses a very efficient column store compressed format called Parquet, and it simulates having a real database. So you would bring it in and then save it as a Parquet format, but you'll get transactional supports logging. And the biggest reason for doing this is so that people can update the data in place without having to reload and things like that. So it's to get some of the benefits of relational database. Now we've got jobs. If we want to create a job, you can see I've created some. I can say create a job here. A job is nothing more than a notebook we want to have run. So I can say my test job. I can select a notebook that I want to run. I'm not going to do this because I've done this before and then I find the job's running crazy. But I can select a notebook, a jar. I can configure the Spark Submit. So I can configure how I want it to run. I can set an edit here. Excuse me, schedule my job every hour. Not a good idea for this, but every week, say at a certain day and time. So I have a lot of ways to schedule. This is really essential. Having a batch job scheduler in data-centric applications, I find completely necessary, because you might want to say data is coming in on blob storage every Sunday night or sometime. You want to be able to go out, ingest it, format it. Maybe you want to run it through some transformations and things while people are out of work and have it ready the next morning. Things like that are really important, and having a job scheduler is just invaluable. So I think that's really great. They're adding a lot of cool stuff here, which I can get into more. Again, not as part of this series, probably maybe a little bit at the end, the models. This gets into like MLflow and the fact you can save models. What I mean is like predictive models, machine learning trained models. So this is really cool stuff they're adding. I'm excited to see more of what they're doing here, because I did do some of it in my book, but it's emerging quickly. All right, so we've got a lot of stuff, got a lot of books there. We're going to go through a lot of different codes. We've seen the cells, how to use notebooks. We've seen the job scheduler. We've seen all the things there. We've seen libraries. We've seen jobs. One of the things I can look at here, we also can go in and looking at this. You know, we saw this. We can edit and do things on a cluster and then change it as well. So there's a lot of options. I'm just trying to make sure we've covered everything. One thing I should also cover is that we can go over here and we can do the set the user settings. And again, this is where you would do Git integration with what we're doing, notebooks. We can do admin console. Now in here we can add groups. We can set up, you know, who can do what in the workspace, we have access control. So we can turn on features of who can do what, and whether or not we even want access control, like workspace access control, we can disable it. It's enabled. We have all kinds of different places where we can turn on security options, initialization scripts, groups, users. All right, so hopefully I've covered everything. I'm looking at things saying, have I touched on everything? I hope I have. I would suggest if you're not sure what to do and you want to explore, go to the top brick thing at the top, because that will show you common tasks you can do. So, oh, I want to create a notebook. Oh, I want to create a cluster. If I go back to the cluster, one thing you'll see also worth mentioning actually is very often when you hover over things, they show up. When you don't, they don't. So if I want to see the Spark UI, I can hover over it and then it shows up. So be aware of that, because sometimes I'm like, why doesn't something work? In fact, I want to show you one more thing related to that, this Python notebook. How do I insert a new cell? Well, the easiest way is actually hovering at the bottom, click the plus sign. Not obvious, right? Hover on the top and you can click above, right? Now you can also do it this way and say add cell above and below, but this is really the easiest way to do that. So again, when in doubt, hover over things and see what shows up. That's my recommendation. So what we saw was the Databricks workspace, I'll call it that, Databricks workspace portal on the left. And on the right, pivoted, is sort of the Spark functionality. So that's representative of the Spark engine. So this is what we got going on. We saw notebooks, we saw integrated blob storage, which is treated like local file storage, which I really like because it just makes it easy. You don't have to start immediately worrying about connecting to some external storage. We saw how easy it is to create clusters, and we can create any number we want with the parameters we want. I would suggest for people who have Databricks in a company to control the cluster creation ability. Make sure it's people you trust who should be able to create clusters. There are different settings you can say someone can create, but they can't. They can create or start. Other people can just say they can start the cluster, but they can't create it. So there are settings you may want to control from that standpoint, so that you don't have people just willy-nilly creating big clusters, because they may not be really fully cognizant of the costs involved. Also setting time limits. It might be good to kind of have one person who defines the clusters with appropriate time limits and max and min resources, and then let other people just start them when they need them. So the job scheduler, we saw secure collaboration and the permissions we can set, language extensions. Didn't really go over that too much. We did see that we can do things like query the blob storage like the fs commands, but there's also utilities like dbutils. In this case, this one saying fs mount, if you can see it, it's actually a Databricks specific thing that allows us, that function will connect us to blob storage somewhere else outside of our workspace, that we may have on our subscription, and then treat it like mount it, and then we can treat it like a local storage, like another folder. And optimizations. So again, we took a look at things here. We took a tour of the workspace, creating a cluster, uploading data. Didn't mention that again. We put data up in the cluster. We don't have to do that, and we later we'll see that we can just upload the files and then use code to create the Hive SQL layer on top. We looked at using notebooks, dashboards, importing. Dashboards are pretty cool. The visuals and all the things we can do there. A lot of cool stuff. And of course, libraries. So we got a lot of different stuff here in jobs. That's it. I know that's a lot, pretty intense. It was meant to be kind of a smorgasbord of all the different things to give you a sense of Databricks, its functionality, and everything we saw for the most part, that whole portal and all the things I demonstrated is what you don't get in Spark. So Apache Spark doesn't come with that. It's got the raw engine underneath, and that's it. So when I get to the point I demonstrate using HD Insight and creating a PaaS implementation of Apache Spark, you'll see what we can do there, and even that's being by the courtesy, if you will, of Microsoft adding some extra things to make it a little easier. Thank you. Please like, share, subscribe, put comments in. I like to hear comments, especially if you find these things useful or how it might have helped you. It keeps me going. So thank you.